Hi guys, we are going to do section 10.5, so we're going to start a different kind of function. So we have been on quadratics where your x is being squared for a really long time. Okay, and if you remember, when x was being squared, you had a parabola of some sort. Okay, those were quadratics. We are shifting gears completely, and we are starting a new type of function, and we're going to start with what are called exponential functions today. So hopefully exponential sounds a little bit familiar to you. First of all the stuff we're going through with the coronavirus, the whole point was to stop this. The whole reason we're not in school is to stop it from being an exponential curve. So an exponential curve starts out kind of slow and then it flies up very quickly. Okay, you've probably seen this if you've watched anything on the news. So the whole social distancing idea is to stop it from doing this and going up really quickly and try to make it go more up and then come back down, which is why they always say flatten the curve. So we are trying to get this point right here, instead of continuing to be exponential, we're trying to get it to be quadratic and come back down. Okay, so that's just a little bit how it's relevant to what we're doing, what's going on right now. An exponential function in math terms is something that goes up very quickly or comes down very quickly. Exponential sounds like exponent, okay, and that's exactly what this has to do with. Everything that we do has to do with your highest powers. So if you remember, like your linear functions, your highest power, y equals mx plus b, the highest power of x was 1, okay? With quadratics, you had ax squared plus bx plus c because your highest power of x was 2. Now, everything has to do with your exponents. In exponential functions, your exponent is actually your variable. So instead of it being a 1 or a 2 or a 3, your exponent is your x. So it looks something like this. F of x equals 2 to the x power. So see how the x is your variable and it is your exponent. If what is changing, your variable is your exponent, that's what's going to cause these exponential curves, very quickly increasing or very quickly decreasing. So just a couple things about exponentials. It occurs when your variable is your exponent, so we just said that. The graph either increases or decreases rapidly, like very, very fast. So if you look over here, this one's increasing rapidly. This one is decreasing rapidly, okay? The other strange thing about exponentials is that they never touch the x-axis. So down here, it gets closer and closer and closer, but it never actually hits the x-axis. Same thing when it's decreasing. It flies down really fast, and then it just bottoms out, and it just goes kind of straight across and never actually touches the x-axis, okay? So exponential growth, growing very quickly. Exponential decay is decreasing very quickly. So if you look at this function, this says graph this function of y equals 3 to the x power. The fact that your x is your exponent means that this is going to be an exponential function. And you're going to plug in the x values exactly like you would any other time. So if we remember what we would have done, so we would say 3 caret and then -2, and then 3 caret -1, 3 caret 0, 3 caret 1, 3 caret 2, okay? Because we are just plugging in these x values over here for the x in my exponent. So in your calculators, you just put those in, so 3 to the -2nd. When you do that, you're going to get a crazy number. It's going to be 0.1 repeating. Okay, so it's really, really small. So we just write that down. When you do x or 3 to the -1, again, you're going to get this time 3 repeating. So it's slightly bigger than it was before. hopefully this third one you don't have to put in your calculator, because anything to the 0 power is 1. Anything to the first power is itself, so 3 to the first is just 3. And then 3 squared is 9. Okay? So once you have all those points, you can come over here and you can graph them. So negative 3. Negative 2, sorry. Negative 2 and then 0.1. So negative 2 to the left, and then 0.1 repeating is barely up off of that x-axis, like at all. It's teeny tiny. And then the next one was negative 1.3, so it's still teeny tiny and it's slightly higher than the other one. So barely increases. Then 0, 1, so 0 left and right, up 1. And then 1, 3, so 1 to the right, up 3. And then all of a sudden we're over at 2 and we're already up at 9. So it's already increased really, really quickly. Okay, so once you have those points, then we're just going to connect them in this curve. You know it's going to keep coming up to the right. To the left, be careful because it's going to not touch the x-axis. It's just kind of going to slowly inch its way down, but it's never actually going to touch it. Okay, so that's that one when you graph it. And is that one increasing or decreasing? Well, just like when you're talking about lines, if we're going from left to right, this is going up, so this is increasing. Okay, let's look at the next one. So this one is 1/2 to the x power. So this time you're going to do, in your calculator, you're going to do 1/2 and then caret, and then what you're raising to the power is what's going to be changing. Okay, so it's always 1/2 to something, because the base isn't changing, it's the exponent, because the exponent is your variable, so that's what's going to change. So here you're going to do 1/2 to the negative second, negative first, 0, 1, and 2. So when you do 1/2 to the negative second, this time you're going to get a normal number. You got 4. And then 1/2 to the negative first, you get 2. 1/2 to the 0, anything to the 0 power is 1. 1/2 to the first is going to be 1/2 or 0.5. If it's easier sometimes to graph decimals, you can do that. So you can do 0.5. And then 1/2 squared is 0.25. So go ahead and graph these points. So negative 2 on the x-axis, 4 on the y. So negative 2 goes 2 to the left and then up 4. And then negative 1 was at 2, so left 1, up 2. And then 0, 1 is a point still. And then we go 1.5, so 1 to the right and then halfway up. And then 2 is only a quarter of the way up. Now this one, if you look at it, looks like it's going to go up to the left and come down and get closer to the x-axis off to the right, but again, it's never going to touch the x-axis. So for this one, if you look from left to right, this one is going down, so this is a decreasing function. Okay? Now, when do they go up and when do they come down? What was the difference between these two functions? The first one had a whole number as the base. 3. 3 is a whole number. So when that 3 was bigger than 1, our graph went up. This one had a fraction, 1/2, as your base. That 1/2 was smaller than 1, so it made the graph decrease. Notice it's not a negative 1/2, okay? You can't have a negative base when it comes to exponential functions, because otherwise it would bounce back and forth between positives and negatives. If this would have been a negative 1/2, then this would have been a negative, and this would be positive, negative, positive, negative, and your graph wouldn't be a smooth curve. So you have to have a positive value in the front. Okay, this base has to be positive. So unlike quadratics, it's not based on positive and negative, whether it's increasing or decreasing. It's based strictly on whether this is a whole number or a fraction. Okay. So we just plugged numbers in, we graphed them, and we decided if it was increasing or decreasing by looking at the graph. You can also tell if it's increasing or decreasing by looking at the chart that you made. So if you look at the chart here, the y's start out small and they get larger. That's increasing. As the x increases, so do the y's. This one, as the x gets bigger, your y's start out at 4, but they end up down at 0.25, so that one's decreasing. So you can tell also by looking at the numbers, not just the graph, whether it's increasing or decreasing. Okay? Your homework is just the 10.5a worksheet. And if you have any questions, you can just Zoom us. Bye, guys.